Hi, this is the final part of the Earth's motion around Sun video series. So in this video, what we are trying to understand is how the loop pattern change as a result of change in the velocities of both of these planets. So in the last video, what we have done is we have written a function for getting the relative position of Mars with respect to Earth. And we are calling that function within draw loop. So what happens is the relative position will be added to this array and we'll be using that array to trace the path. Now in this video what we have to do is draw the complete loop pattern in a single step. So within the first pass of the draw loop itself, we want to get all the relative positions. So for that, I'm going to write a function get all relative pose in one step. Then I want two variables for keeping track of the theta values of the planets. And I'll be running the theta from 0 to pi. Let Earth theta equal to 0, comma, Mars theta equal to 0. And I'm having a while loop. So the termination condition of the while loop will be either of these values becoming 2 pi. So Earth theta less than or equal to 2 into pi, or Earth Mars theta less than or equal to 2 into pi. And then I'm going to increment this theta by the respective angular velocities. Mars theta plus equal to Mars dot w. Then I'm going to use these two values to uh, calculate the position vectors, uh, two position vectors. So let const Earth pose equal to create vector, const Mars pose equal to create vector, and then dot r into cos of Earth theta, Earth dot r into sine of Earth theta. Same thing I'm going to repeat for Mars. Theta, theta. Then I'm going to store the relative position in a variable Mars pose dot sub Earth pose. Now what am I going to do is to push the relative position value to this array. So we already have the code for tracing the path from this array. So if we push the correct values, we should be uh, able to trace uh, the path automatically. So relative pose array dot push x should be relative pose dot x, y should be relative pose dot y, and then we have to make this array empty value before running the loop, otherwise the values will be getting filled indefinitely. And then I'm going to call this function instead of this function. Okay, we got the complete loop pattern, and then I'm going to change this to white, and instead of this point I'm going to use line to make the path a little bit more smooth. +1 +1, it should be -1. Okay, next I'm going to create two sliders, Earth slider, Mars slider, then earth slider equal to create slider, then Mars slider equal to create slider. So the minimum value should be 0.01, max can be 0.06, and the value current value is 0.03, step can be 001, minimum value can be 0.05, 0.01, 0.03 by 4, 0.001. Okay, then we need to have a callback function for the change in this slider value. So on slider change, then again Mars slider, then I'm going to write function on slider change, then I'm going to change the velocity of earth slider value, Mars dot w equal to Mars slider dot value. If I change this, yes, we are getting the we are able to change the loop pattern. We also have to reset the theta value, Mars dot theta equal to 0. We got the final visualization. So that's all about the in the last video. So as usual, I'll be sharing the code in the description. um, so thank you for watching.